We've all seen the testing pyramids, with the end-to-end tests taking the place at the very top being the slowest and most expensive. A part of why the testing pyramid looks the way it does is that maintaining tests is hard. This usually pushes teams to keep the number of end-to-end tests at a minimum, or even abandon them altogether. The maintenance problem has been such a natural part of end-to-end test automation that we no longer question it. But we should. At Replay, we've been helping companies drive down their end-to-end test flake by getting a deeper understanding of what happens when an end-to-end test script interacts with an application. In this video, I'd like to show you a flake example so you can see Replay in action. In principle, setting up Replay is simply a matter of installing Replay browser and then using it with your test suite. Every test running with the Replay browser generates a replay of your test execution, which you can then examine in Replay DevTools. This example is in Cypress, but besides Cypress, we support all major test frameworks, such as Playwright, Selenium, or WebDriver IO. You can check out the docs for more info. Let's now jump into the analysis of a Flaky test. In my browser window, I have two replays of my test opened. So I have the passing test and also the failing test. And you can see that there's a slight difference between them. This test was trying to find out whether this spinner animation appears. In the passing case, we can clearly see that, and in the failing test, we only see the to-dos being loaded already. So both of these replays act sort of like a video. We have a timeline at the bottom, and we can go back to the start and play this just like you would play a video. But this is actually much smaller than a video and contains a lot more information. Since this is a recording of our test, or as we like to call it, a replay of our test, we can look at the Cypress panel and see all of the commands and API calls that were done during the test execution. In here, I can see the failed assertion that was trying to find an element that had an attribute data test spinner. So if a test is flaky, the best course of action is to try to compare the passing test and the failing test to see what's different. With Replay DevTools, we can dig a little bit deeper and see not only what's different in the test, but also what's different in the application. So let's try to see that. I'm going to open my passing test now and open DevTools. Now in the DevTools, I still see my Cypress panel. In the middle, I have a file viewer, which I'll show you in a minute. And on the right, we have a smaller version of the viewer and also some of the panels, such as console, elements panel, React panel, and even network communication. On the left side, we have a couple of tools that allow us to view comments, explore the files of the application and of the test, search, and a pause information. So let's try using search. And let's find the spinner element to find a little bit more about that. So I'll type in here data test equals to spinner. When I click on the search result, it will reveal the React component that's responsible for showing my spinner. We can make a comparison here and go to the fail test to see if this component is even present in the failing test. I'll jump to the DevTools, go to the left panel to click on search and look for data test element with the value of spinner. And again, I can find the spinner element and see that indeed it is a part of our application. Not only we can view the code, but in this gutter on the left side, we have a number that indicates how many times this line of code was called. As I hover over, you'll see the plus symbol that allows us to add a print statement. But before I show you that, I want to show you one more thing. If I click Command on my keyboard or Shift Command, I can actually travel back to the time where that line of code was executed. So right now on the timeline, I'm around the 4th second of the execution of the fail test. But if I do Command Shift and try to go back, this will take me 2 seconds back. And in the viewer, I can see the spinner element appear. So this confirms that my spinner element is here. So it doesn't seem like there's something wrong with the application now. So let's now try to see the spinner component in its context. I can go to the React panel and search for my spinner component. The React panel shows the whole component tree. So now I can see it is embedded inside this home component. In the right panel, I can see all of the details of that component, but I can also go and click this icon in the top right corner to jump to the code of this component. In the same way that I searched in the whole source, I can perform a search within just this file, pressing Command F on my keyboard will show this search box at the bottom. So I'm going to find my spinner element, and now I can see my spinner element inside this file. If I take a look on how this component is actually being used, I can see that it is part of a condition. There's a state variable that's either going to show my spinner component or my to-do list. The really cool thing about replay is that I can take a look at this loaded variable and see how the state was changing during the recording. I'll scroll up to find the definition of this state variable and add a print statement right below. Instead of this default text, I'm going to type loaded, hit enter, and switch to my console. This is like adding a console log to your code, but instead I didn't have to change my code, I just added that console log into my recording. In the console, I can now see how that state changed across the time. So we can clearly see that at some point our spinner element is rendered and then it disappears. So let's now try to find out what causes changes in this. Up in the definition, I can see that there's a setLoaded mutating function. So let's try to search for that. As I type it in the search, I can see that the setLoaded is actually called with the value of true after we fetch our to-dos. This fetch to-dos is a function coming from a fetch to-dos atom that's imported from the atoms file. I'll hit Command P and search for atoms file. And now I can see that the fetch to-dos item is making an API call to get our to-dos. So now we know that not only the loaded variable changes the state and effectively rendering or hiding our spinner element, but it's also an API call. So let's take a look into the network panel. I'll go ahead, open the network panel, and search for our to-dos. We can see the API call being made, and as I click on one of my to-dos, I'll get the details of this network call. I can take a look at the headers, response, stack trace, and even see the timings. What's interesting about this timing is that the total time it took for this response was 32 milliseconds. That's quite fast, and if we want to test for the loading animation, chances are our test is not going to catch it. If I go back to my viewer and open the Cypress panel, I can examine my visit command and see what the state of my application was after it finished, which basically shows a blank page, and compare that to my get command, where I see my elements being already loaded. It seems like there was some time between visiting the application and my get command that Cypress was not able to catch. So let's go back to our VS Code and make our test more stable. In my test, I'm already using intercept command to catch the API to-dos call and then throttle the response. This was added exactly because I wanted to have some time for the spinner animation to appear. But it is not really that effective, because if I use throttle and effectively limit the throughput of the response, the size of the response is going to dictate how fast will the response come back. So maybe we need to add something more deterministic. So let's change this set throttle to set delay and set that to 100 milliseconds. This way, my Cypress script is going to have enough time in between the commands to find that spinner element and assert that it is visible. And now our test is stabilized. Normally, it's difficult to test changes that could happen really quickly, especially when the backend is out of our control. But with replay, it doesn't really matter if the response comes back in 10 milliseconds or 100 milliseconds. Replay protocol captures the operating system calls, so even if an element renders for a short period of time, it can be observed. As I mentioned in the beginning, test maintenance costs can grow frustratingly high. But a part of that maintenance can be very efficiently mitigated by getting a proper insight into your test run. You can get more insight too. Check out the documentation to see how you can create your first test recording or integrate replay into your end-to-end test suite. See you next time.